So in section 3.3, which is the last section, we kind of studied averages, mean, median, mode, and mid-range. And in this section, we're going to talk about how spread out the data is, or how the numbers are that made up the mean, median, and mode. And the two topics that we're going to study in this section are the simple topic of range, which is different than mid-range. And then the other topic is standard deviation. Both of these words, or both of these things, objects, they measure how spread out the data is, or how grouped. Either measure how spread out or I'll say grouped the numbers are. Let me just make up a real quick example to give you an idea of what I mean about how spread out and how grouped the numbers are. Let's just make up a person. Let's say Lois scores on her first 3 tests in Math 142 are, how about 79, 80, and 81, and Michelle's scores are 60, 80, and 100. So the first thing I'm going to do for each of these students is first find each student's mean average. For Lois, I'll find her mean by adding up her 3 scores and dividing by 3. I could do that all in one quick computation on my calculator. So I could go 79 plus 80 plus 81 divided by 3. Lois's average, her mean average, is 80. And I'll do the same for Michelle. For Michelle, to find her mean, I'm going to go 60 plus 80 plus 100 over 3. And let me do that again on my calculator. So just 60 plus 80 plus 100 divided by 3. And she also averages an 80. So for this number 1, I can say Lois average, or Lois's mean, equals 80. Michelle's mean equals 80. So they both have exactly the same mean. So the mean doesn't tell me how spread out the numbers are, because Lois's test scores are bunched up real tightly, where Michelle's scores aren't bunched up so tightly. The 2 concepts we get in this section will help us determine, how spread out the numbers are. And the first concept, which is the easier one, is the range. Well, let me do question 2 here. Find the range of each student's scores or grades. And that's super easy to find. The range from a set of numbers is just the high number minus the low number. So for Lois, her range is going to equal 81 minus 79, and that's 2. So part of my answer here is going to say Lois range equals 2. If I did the same thing for Michelle and did her range, I'm going to take the highest score, which is 100, minus the lowest score, which is 60, and her range is 40. So the range certainly tells me how spread out the data is, but the range can be deceptive because it's really strongly influenced by a single outlier. For instance, like if these were the scores and I asked you to find the range, if these were somebody's test scores, and we did like 10 tests in the class, and their scores were 30, 88, 88, 88, 88, 88. They scored 88 in every test and they scored 30 on one test. Well, the range of these test scores would still be a big number, even though most of the scores are about the same. The range just takes the high minus the low, and it's impacted by the smallest and the largest number, and not the numbers in the middle. But it is a way to differentiate between groups of data that could even have the same average. The third concept is the ugly concept that we have to learn how to do in this section. And it's a better way to measure how spread out the numbers are. So for 3, I'm going to find the standard deviation of each student's scores. This is a messy computation to do by hand. In general, I'd say the standard deviation is the average distance each score is from the mean. It turns out that this is probably a little too simplistic of a definition. It's more the standard deviation is the average squared distance each score is from its mean, and even that's even a little simplistic. But I think standard deviation is, in some sense, an average of how far each score is from the mean. This score, for Lois's test, her first score is 1 from the mean, her second score is 0 from the mean, her third score is 1 from the mean. Somehow I'm going to average those three numbers, 1, 0, and 1, and come up with a standard deviation, but it's more complicated than that. Similarly, Michelle's score of 60 is 20 below her mean. Her score of 80 is 0, it's tied with the mean, and her score of 100 is 20 above the mean. I want to find the average distance. If I want to find the average distance each one of those scores is from the mean of 80, I can find the standard deviation. Let me show you how to do this on your calculator first, and that's all you're going to be responsible for. And then I'll show you in a bit how to do it by hand. But because Michelle's scores are wider, they're more varied than Lois's score, even though they have the same average of 80, I'll expect the standard deviation of Michelle's scores to be larger than the standard deviation of Lois's scores. So to find standard deviation on my calculator, I've got a chunk of work to do. And that chunk of work first involves getting the test scores on my calculator. So I'm going to do on my calculator. So how to do find Lois's standard deviation of her test scores. using my calculator. So the first thing I do to find a standard deviation of her test scores, again, just in case you don't have them handy, were 79, 80, and 81. Clear out my main screen just so I don't see any junk there. The first thing I'm going to do is hit the stat button. So I just plunk out and I hit the stat button. And when I hit the stat button, in the left-hand column, edit is highlighted. And in the numbers, 1 is blacked out. That's what I need to have. Once you get that highlighted, the edit highlighted in the left-hand column, or the top of the 3 choices, edit, calc, and tests, and the edit highlighted in the left-hand column, you just hit the enter button. So after these two are happening at the same time, I'm going to hit my enter key. Best case scenario, when I hit my enter key, I see list 1, list 2, list 3. If I don't see list 1, list 2, and list 3, I might be able to go up to the top and arrow around and find list 1 and list 2 and list 3. But let's say that you don't have a list 1. You just can't find it. Like I just deleted my list 1. I can delete my list 3 if I want by just hitting the delete. If you don't see list 1, we need to insert it. How do we insert it? It's easy enough. We hit the second button. So this is only if you can't find L1, which means list 1. To insert it, if you're missing it in L1, you hit second and then the delete key. And that opens up a new list. And now I'm going to hit second and the 1 key for list 1. And then I'm going to hit enter. So let me go through that process again. So if you don't have a list 1, to enter a list 1, you hit second and the delete key. That'll open up a blank list. Then you hit second and 1 and then hit enter. So now my list 1 is here, and in my list 1, I just want to enter the numbers 79, 80, and 81. I don't care that there's numbers in list 2. I don't care anything except about list 1. In order to get the list 1 ready to handle the numbers 79, 80, and 81, I'm using my up and down arrow here. I'm going to hit delete next to all the numbers in my list 1 to get it all fresh and clear. So you should be starting with a list 1 that looks like that. You're going to type the number 79, hit the enter key, type the number 80, hit the enter key, type the number 81, hit the enter key. Done with that. So we started off, we hit the stat button, we hit enter and edit, we found list 1, or we created a list 1, we entered the 3 values. Once you get that done, so now we entered the test scores in L1, which stands for list 1. After you have that done, then you're going to hit the stat button a second time. That's going to take me to that screen that first we had the edit and the 1 highlighted. I need to arrow over 1, and I need to simultaneously have the calc highlighted in the middle column and option 1 variable statistics, highlighted in the numbers. If you can get your calculator to have that, the calc in the middle, the 1 variable stats in the left, you're going to hit enter twice, assuming you have your data in list 1. So I'm going to hit enter once and enter twice. And what it's going to do is it's going to calculate a bunch of numbers. One of them is actually going to be the average of 80. And some of the other numbers are numbers that you need if you do standard deviation computations by hand. It gives you some of the numbers to save you some work. And one of the numbers, the one we're looking for, is going to have an S and an X next to it. This is the number that's going to be what I'm going to call standard deviation. And for this data, it's going to measure how far Lois's scores are on average from the mean of 80. So I hit enter once and then enter twice. I look for this S of X and I get 1. It says on average each score is 1 from the mean of 80, and that kind of makes sense. So when I go to answer this question, find the standard deviation of each student's test score, I can say Lois's standard deviation equals 1. And the next thing I'm going to do is do Michelle's standard deviation. And I'm going to do exactly the same procedure on my calculator. In a second here, I'm going to show you how to compute standard deviation by hand. You're not responsible to do standard deviation by hand on the test. I prefer you using your calculator. It's kind of a silly thing to do by hand if your calculator can do it, because it's just very tedious. So let me find Michelle's now. So to find Michelle's standard deviation, well, I need to know her test score. And her 3 test scores were 60, 80, and 100. It would be nice if the standard deviation comes out to 20. I don't think it will. It's more complicated than just figuring out how far 2 of the numbers are from the mean. I don't think it's going to come out to that. So how do I do Michelle's standard deviation on my calculator? First, I hit the stat button. I make sure that the edit in the left-hand column and the edit on the top row in the edit is highlighted. After that edit and 1 are simultaneously blacked out, you hit the enter key. Then I look for list 1, and in list 1 I'm going to enter her test scores. I don't really need to delete her test scores. I can just type the new ones in. I could type her 3 scores of 60, 80, and 100. I can type those in. So now her 3 test scores are in. So I went through step 1. I hit the stat button. I hit enter when the edit and the 1 are highlighted. I entered her 3 scores, so I'm done with those 2 steps. The next thing I'm going to do is hit the stat button 1 more time. I'm going to right arrow over to calc. Make sure to have calc on the top and 1 variable stats on the number 1 highlighted, and then I hit enter twice, enter once, enter twice. Oh, it just come out to 20. This is such a simple example with 3 numbers that the standard deviation almost feels like it should. It won't always feel like it should. So on my calculator, the number I'm going to pull off here is the standard deviation of Michelle's score, which is 20. So I've answered the questions for that I wanted to talk about these 3 pieces of data. So both Lois and Michelle have an average, a mean of 80 for their 3 tests. The range of Lois's scores were only 2 because her scores were really bunched tightly. The range of Michelle's scores was 40 because her scores were wildly different. The range is just the high score minus the low score. Super easy to do by hand. And then I did the standard deviation for both Lois's and Michelle's score on my calculator. I'll show you how to do standard deviation by hand, and it's a mess. And you can fast forward, and what you would want to fast forward to if you were wanting to going forever. You can fast forward all the way to the homework. I'm kind of shortcutting the lecture that I gave last time. I've got a bunch of stuff typed up, and quite honestly, as I read through the stuff that I have typed up, I thought it was too complicated, so I thought I'd try to make a more understandable, easy example to go through. So if you forward to the part of the video where I start doing the homework questions, more power to you. You don't have to learn how to do this by hand. If you have the desire, I'm going to show you how to do one of these scores, or maybe both of them by hand. So let me compute first the more complicated. Let me do Michelle's standard deviation by hand. You absolutely don't have to know how to do this if you have the calculator that computes standard deviation. So her 3 test scores were 60, 80, and 100. And the first thing I did is I computed the mean of her score, and we got the average of Michelle's 3 test scores to be 80. What I'm going to do to find her standard deviation is going to make a big table. In the first column, I'm going to put her test scores. And Michelle's test scores were 60, 80, and 100. The next column, I'm going to take her score minus the mean. So the score of 60, I'm going to minus the mean of 80, and 60 minus 80 is negative 20. I'm going to take the score of 80 and subtract the mean of 80. 80 minus 80 is 0. And take the score of 100 and minus the mean of 80 and get 20. The next thing I'm going to do is I'm going to square these numbers. So I'm going to go negative 20 squared, which is going to be a positive number because when you square any number it becomes positive. Negative 20 squared is positive 400. I'm going to do 0 squared, and I don't need my calculator to know that that's 0. And I'm going to do positive 20 squared. I don't really need my calculator to know that that's 400 either. So I have these 3 columns, and I now want to total these numbers. So I'm going to add up those numbers. 400 plus 0 plus 400 is 800. What I'm going to do now to find the standard deviation is I'm going to take the square root of this number divided by the number of test scores minus 1. So Michelle's standard deviation is going to be gotten by forming a fraction. In the numerator, it's going to be this number. In the denominator, it's the number of test scores minus 1. So it's going to be the square root of 800 over 2. The 3 minus 1, it comes from a formula. It's the number of data points minus 1. The 3 here is the number of data points. And let me just do this real quickly on my calculator. I'm going to go second square root of 800 divided by 2, and I get standard deviation equals 20. So it's a tedious computation, but it's not ridiculous. Let me do one more standard deviation. I'll do a Lois's standard deviation by hand just to show you how to do it. And then again, you're not responsible to do this at all by hand. So I'm going to do Lois's standard deviation. Lois's 3 test scores were 79, 80, and 81. And when we did the average of her 3 test scores, we got 80. So how would I do the standard deviation if I didn't have a calculator? I didn't care to use my calculator to find it. I'm going to make 3 columns. The first column is going to be the scores. Lois's scores were 79, 80, and 81. Second column, I'm going to do the score minus the mean. So I'm going to go 79, which is a score, minus the average that we figured, minus 80. It's going to give me negative 1. And then I'm going to do 80 minus 80. That's going to give me 0. And then 81 minus 80. That's going to give me 1. I'm going to fill out my last column here in a second. Hiccup. So now I'm going to square each number. The numbers that I'm going to square are the negative 1, the 0, and the 1. So in this column, I'm going to go negative 1 squared, which is negative 1 times negative 1, which is positive 1. 0 squared, which is 0 times 0, which is 0. 1 squared is 1 times 1, which is 1. Then I total up these 3 numbers. I'm going to add up those numbers, 1 plus 0 plus 1. 1 plus 0 plus 1 equals to 2. The standard deviation for Lois's scores is going to be the big square root In the numerator, it's the total of this right-hand column, which is 2. And the denominator, it's the number of scores minus 1. Here there's 3 scores. If there were 10 scores, it would be 10 minus 1. But here, there were just 3 scores, so it's going to be 3 minus 1. This is always the number of data points minus 1. And then this is just going to be the square root of 2 over 2, because the denominator comes out to 2. And I could do this without my calculator. This is just the square root of 1, because 2 divided by 2 is 1. And that's the 1 that my calculator gave me. So there's 2 times I did the standard deviation by hand. I won't do the standard deviation of any problem by hand again, because I just don't think it's that important of a skill to be able to do. And if you took a statistics class, which is the class that you really start to beat to death standard deviation, you'll be doing it by some sort of technology. It probably won't be this calculator. It'll probably be some program. So I skipped a lot of what I had typed up, just because I didn't really think it was that great anymore. After 4 years or 3 years of letting that rest, I look at it and I wasn't that excited about it. So the big thing is we need to be able to compute range by hand, and we need to be able to compute standard deviation either by hand or using our calculator. And both the numbers that we're going to give a measurement of how spread out the data is. Let me walk through problem 1 with you, just to make sure you can handle the computations that you need. So for problem 1, I'm asked to find the range. That's super easy. To do the range, it's just the highest number minus the lowest number. So I looked at the 5 data points, 6 data points, and to compute the range, I'm going to go 14 minus 8, and 14 minus 8 is... Whoops, I missed up. I couldn't actually pick out the highest number for whatever reason. I should have said the range is 16 minus 8, because 16 is clearly bigger than 14. So the range is going to be 16 minus 8, which is 8. Next thing I'm going to do is the standard deviation, all on my calculator. I don't care to do a single standard deviation by hand unless somebody made me to do it, because I have to do the 3 columns for that table. I've got to calculate the average, and that's just a mess. In the instructions it says round to the nearest hundredth, which means round to 2 decimal places. So let me figure out the standard deviation for these numbers. So let's go through that same process again. I hit the stat button. After I hit the stat button, I could just hit enter. And I have to have my list 1 ready. My list 1 has numbers in it. I'm just going to type over those numbers. I don't need to delete them. I'm going to type the numbers in the order that they came. I don't need to rearrange the numbers when I do standard deviation on my calculator. So I'm going to go 10 and then enter, 10 and then enter, 14 and then enter, 16 and then enter, 8 then enter, and 8 then enter. So I have to have all the numbers in, even if there's duplicated numbers. After I get the numbers in, and I'm happy that I have them all in correct, I hit the stat button. Now I arrow over to CALC for calc, and then have the 1 variable stats highlighted, and you hit enter twice, and you're looking for the S number. Enter once, enter twice. The S number that I get, it means standard deviation, and 3.286. In terms of the by hand, that X bar right there, that 11, that's the mean. And this 780, that's the right-hand column added up. So to do this by hand, it's going to be the square root of 780 divided by 5. So this number right here, if I did the square root of 780 divided by 5, it should give me that 3.286, because that sum of x squared, that's the sum of the right-hand column, and you divide by n minus 1. I'm not interested in doing that. I'm just interested in getting an answer. I'm going to round that to 2 decimals, and that 286 is going to round to 3.29. That's all I need to do for number 1. I'll let you go through and work with number 3, and I'll do number 4 real quickly. So in order to do number 4, I need to know the high number and the low number to get the range. My range is going to be 92 minus 1. It's going to be 91. I could do the standard deviation by hand, but I really have no desire to do the standard deviation by hand. So let me just go through the process just in case you're not getting it yet. So to do the standard deviation on your calculator, you hit the stat button. Once the edit and the 1 are highlighted, you hit enter. And I'm going to enter the data. 1 equals 3 equals 71. Enter, I guess, 8. Enter 92. Enter 63. Enter. I have the data in. Once I have the data in, I hit the stat button. I arrow over to calc, and I hit enter twice. And my calculator gives me 40.267, which I'm going to round to 40.27 for my standard deviation. It turns out that the concept of standard deviation is kind of like the foundation of a statistics class, and you do so much with standard deviation in a statistics class that's going to drive you crazy probably. And this is not that. This is just given the idea that the standard deviation measures how far data is spread out. We'll do a word problem here in a second to help us kind of reinforce that. When you get your answer for problem 3, assuming my key is correct, I have a range of 150, and for the standard deviation I have 54.01. Let me flash 5 up here and you can pause the video. I won't even do 6 because I'm assuming you can do this and you don't need to see another example. For number 5, when you go to write your answer for number 5, hopefully you can quickly get the range because that's the easy one. It's 395, and then hopefully you can get the standard deviation. I might be lazy and write S period D period to mean standard deviation rather than writing out the whole word. And I get 166.46. So let me walk through a word problem with you. We have 2 word problems here. There's only 2 problems left in the section, a problem 7 and a problem 8. And I will just walk through problem 7 with you and won't do problem 8. What did I do? Somewhere I had the answers around that I was looking at. Oh, get them back. So let's look at this problem, and this will give us a better idea, or maybe a more deep understanding of standard deviation, but by no means a complete understanding of standard deviation. So at the steakhouse grill, steaks are cut into 12-ounce portions when they are ordered by a customer. For the past month, the manager of the steakhouse grill has been trying to determine which cook can most accurately portion out the meat. The manager collected the mean sample of portions for a few weeks for both of his cooks. The results are summarized in his table below. So for week 1, Opie's steaks, which are supposed to be 12-ounce portions, were 12.5 ounces. Maynard's were exactly 12s. You can tell I'm old. Opie is from the Andy Griffith Show. And, oh gosh, what was Maynard's show? It's from the 50s. Dobie Gillis. In week 2, Opie's steaks were 12.3 ounces, Maynard's 12.2. Week 4, they both average 11.8. In week 5, Opie's were 11.2 and Maynard's were 12.4. So first part here says compute the mean portion, which means the average. So I'm going to do Opie's mean. And to find the average of Opie's steaks, I'm just going to add up his steak cuts, his 12.5 ounce average plus his 12.3 ounce average plus his 11.8 plus 11.2, and I'm going to divide by 4, and I'm no desire to do that anywhere else but on my calculator. So in a parentheses, I'm going to put that numerator, and then I'm going to divide by 4 because there's 4 scores I'm averaging. And for Opie, I get his average is 11.95. Maynard was played by Gilligan from Gilligan's Island, and Opie, that's Ron Howard, who is a famous movie director. For Maynard's average, I'm going to take his 12.0 plus his 12.2 plus his 11.8 plus his 12.4 and divide by 4. Try to attempt that on my calculator as well. 12.0 plus 12.2 plus 11.8 plus 12.4 divided by 4, and I get 12.1. So they're both right around the 12 ounces on average. Opie's a little bit shy of the 12-ounce goal, and Maynard's a little bit high of the 12-ounce goal, but for my part A, I'm going to say Opie is 11.95. I guess this is ounces, so I'll put ounces next to it. And Maynard is 12.1 ounces. Next, I'm going to do the standard deviations for each. And easy enough to do Opie's standard deviation and Maynard's standard deviation. To do Opie's standard deviation, I need to get the scores on here. So I'm going to hit the stat button. I'm going to hit enter on edit. Now my list only needs to have 4 numbers. My list 1, it has 6. Let me delete a couple of these just by hitting the delete key. I can delete all the numbers if I care to. I only needed really to delete a couple. But now I'm going to enter Opie's scores as weights. And then I hit the stat button, go over to calc, and then hit enter twice. His average of 11.95 is there. And for a standard deviation for Opie, so I'm going to say Opie's standard deviation is 0.58 ounces, which means he's about, you can tell he's got a pretty, he's off a lot. Here he's a half a pound high, he's 0.8 of a pound short. So on average, his standard deviation in some sense, he's 0.6 off what he should be in terms of a standard deviation. Let me do the same thing for Maynard. So I'm going to enter Maynard's data. I'm going to hit stat and enter, and then I'm going to go 12.0, 12.3, 11.8, and 12.4. Got the data in. I'm going to hit stat, over to calc, and then hit enter twice. And for the S number, I see 0.275. I'm going to round that up to 0.28. Interesting. I wonder if I entered one of the data points right, because my answer is not matching up what I have written down. So I have 12. Haha! I should have entered 12.2 here, and then 11.8 and 12.4. Let me redo that computation because I entered the wrong week 2 score. Now I'm going to go stat, calc, enter, enter. And this is 0.258. I'm going to round that to 0.26. So I'm done with part 2. Now I go on to part C. So the manager needs to choose a cook, and you need to decide which one you want to pick. Maynard, he's making steaks bigger than he's supposed to because it's 12. We're only supposed to give him 12 ounces. He's giving them 12.1 ounces. Opie's making them smaller. Probably these differences are so close to 12 ounces that a customer wouldn't notice. If every one of Opie's steaks was actually 11.95 ounces and every one of Maynard's steaks was 12.1 ounces, I don't think many customers could tell the difference in size. And Opie might save the company money because he's using smaller cuts. On the other hand, because Opie's standard deviation is so high, he's probably going to get more complaints than Maynard. And this week, Opie's costing us a lot of money because he's making the steaks way too big. Probably nobody's going to complain for his week 1 and week 2. But by the time we get that week 4, maybe somebody's going to complain. If I was picking one of these cooks, and I'm more interested in probably pleasing my customers than saving the few pennies that Opie might have saved you because of his smaller cuts, I might pick Maynard because I think he's more consistent. The smaller standard deviation tells me that his cuts are more consistently close to what I want them to be than what Opie's are. Opie's are wildly kind of varied in some sense. But you could make an argument. You can say, I'd pick Opie because he's making smaller portions on average, and his smaller portions are going to save me money. There isn't a right or wrong answer, but I would guess what I'd be hoping for you to say is that Maynard would probably be the one to choose of these two, just because we're selling our customers a 12-ounce portion, and for the most part, he's right around 12 ounces, whereas Opie gets, I don't know what percentage too high or what percentage too low that is, but Opie, because he's not very consistent, I probably would, if I had to pick one or the other, not based on quality of what they're cooking, just based on the numbers, I'd probably pick Maynard. Of course, if there's many, many more things you choose to make that decision, maybe Maynard doesn't show up to work half the time, and who knows, or maybe Opie just does something better. He gets a better sear in his steak. So you couldn't just make the decision based on the numbers solely. But if I was making the decisions on the numbers and nothing else, that's what I would say for an answer. So, and when I wrote this up, I have the means and the standard deviations for parts A and B. And then when I wrote C, I said Maynard's cuts are more consistent and closer to the desired average. I would pick Maynard. I can see an argument for Opie. If you selected Opie and gave a good reason, I would give you credit. So that's kind of everything. This is really a standard deviation and range kind of light section. This is not by any means even close to scratching the surface of standard deviation. And if you get to take a statistics class, you'll really learn a lot about what standard deviation is used for, because it's used a bunch in mathematics.